Oh hey, you must be here to talk about transformations. While these are three different types of transformations, there are other transformations that we're more interested in. One's dealing with math. So let's go ahead and get started with that right now. So yes, here it is. It's true. We're going to be talking about transformations. So let's go ahead and take a look at some key ideas. So when talking about transformations, there's some things that we need to remember. So before we perform a transformation, we refer to the figure as the pre-image. So before we're moving anything around, before we're performing a transformation on it, we know it's the pre-image. We label the pre-image using letters. So like A, B, C, or triangle D, E, F, we use letters to label it. After we perform the transformation, we refer to the figure as just the image. So the pre-image is before the transformation. After we perform the transformation, we refer to it as the image. And we label this image using a special character that looks like this. It looks like an apostrophe. And we call this character prime. So we would say A prime, B prime, C prime. And when we draw that out, it looks like this: A prime, B prime, C prime. So after we perform a transformation and we have letters there, we're going to label them using our prime symbol. Now let's go ahead and take a look at our first transformation. So our first transformation is called translation, or you better know it as slide. So we're going to be sliding our shape around our coordinate plane. So a horizontal translation is going to move our figure either right or left, and a vertical translation is going to move our figure either up or down. So when we're talking about that in terms of positive or negative, when we're moving positively, we're going to be moving to the right or up, because those are where our positive numbers are. When we're talking about negative, we're going to either be moving left or down, because again, those are where our negative points are. So looking at our example here, triangle ABC, it says translate the figure horizontally +3, and then we're going to move it vertically -2. So those are the things that we're going to have to move our shape. Now the easiest way to do that is we're going to just count our points on our coordinate plane. So right now I have A, and I'm going to be moving it horizontally 3, so 1, 2, 3, and then -2, 1, 2. And I'm going to put my point right there, and as we talked about earlier, we're going to label that with prime, so A prime. I'm going to do the same thing with B, so 1, 2, 3, and then down 1, 2. And again, I'm going to label that point B prime. I'm going to do the same thing with C. 1, 2, 3, down 1, 2, and I'm going to label that C prime. Now notice I'm going to connect all my points, and I'm going to make a triangle. I'm going to make a triangle that looks exactly like the triangle that I had above. It's going to be the same shape, it's going to be the same size, it's going to be congruent. All that happened is that I moved my shape. I slid it across my coordinate plane. Now, that works if I have the graph, but what if I'm just given the points? So A is at -4, +4. So again, those are the points on A. So if I were to apply my transformation of +3, -2, all I'm going to do is add 3, since that's the horizontal, to the X, and then -2 going to the Y, since that's vertical. -4 plus 3 is going to give me -1, and +4 minus 2 is going to give me just regular +2. So now, is that where A prime is? Let's go over and take a look at -1, +2. Yes, so that also works. So if you don't have the coordinate plane, you can just apply the math to find the new coordinate. Now let's move on to reflection. Here we are at reflection, or you better know it as flip. A reflection over our x-axis is going to change the y-coordinate to the opposite. A reflection over the y-axis is going to change the x-coordinate to the opposite. So let's take a look at our examples down below. So the first one on the left says reflect the figure over the y-axis. Now, it's very important to understand which axis you're going to be flipping over. To remind myself, I'm going to shade the y-axis because that's the one I'm going to be flipping over. So I know that my shape needs to flip over this axis and land in the other coordinate. Now, how am I going to do that? There's two ways. I can either count using the graph, or I can use the rule that I was given up above. So let's start with the counting method, and then we'll take a look at our rule. So I can see my first point over here is gone 2 spaces from the y-axis. So I'm going to do the same thing on the other side. 1, 2. Because I want it to just be a mirror image. So the same thing I'm going to do with the point at the bottom. 1, 2. So I'm going to go 1, 2. And I've got another point. I'm going to do the same thing with the third point. So it's gone 1, 2, 3, 4, 5. So I'm going to go 1, 2, 3, 4, 5. And I'm going to do the same thing with the last one. 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5. And again, I've got my rectangle. Again, it's the same shape, same size. I didn't change anything about it. It looks exactly the same. It is congruent. So that works if I just want to do the counting method. So now on the next example, I'm going to do not counting. I'm going to do the math way. So this one, I'm going to be flipping over the x-axis. And when I'm going to flip over the x-axis, I know I'm going to change the y-coordinate to the opposite. So in order to do that, the first thing I need to do is have all of the points. So my first point here is at +1, +5. So my first point is at +1, +5. I'm going to change the y-coordinate to the opposite. So the opposite of +5 is -5. I'm going to do that for the next point as well. So the next point is at +1, +1. So again, I'm going to change the y-coordinate, and the new y-coordinate is going to be -1. And I'm going to do that for the last point, which is at +5, +1. And again, I'm going to change it so that the y-coordinate is the opposite, and the opposite of positive is -1. So now that I have all my new points, I'm going to graph them. So I'm going to go up to 1, and I'm going to go down to -5. I'm going to go over to 1, and I'm going to go down to -1, and I'm going to go over to 5, and I'm going to go down to -1. Then I'm going to connect my points using lines, and as you can see, I made myself a triangle that looks exactly as the same one as above, but I flipped it over the x-axis. And you can see that my shape has flipped over the x-axis. I didn't have to do any counting if I didn't want to. I could just change all of the points to the opposites. And notice that my triangle has ended up flipping over the x-axis like a mirror image. Now let's move on to dilations. Here we are moving on to dilation, or as you better know it as scale. To dilate a figure, remember you always are always going to multiply. You're not going to do anything else to figure out dilation. The only thing you're ever going to do is multiply. Remember, a dilation with a number greater than 1 is going to cause the figure to become larger, and a dilation between 0 and 1 will make that figure smaller. So now we're going to take a look at 2 different dilations that we're going to do, one with a scale factor of 2, the other of a scale factor of 1/2. So what are we going to be multiplying? Well, we're going to be multiplying the points, obviously, so we need to get those points in order to be able to do this correctly. So the first figure that we have there, we're going to grab our first point right here at the top, which is going to be 0, 2. And again, we're going to be multiplying, and since it's a scale factor of 2, we're going to be multiplying those numbers that we have there by 2. So 0 times 2 is 0, 2 times 2 is 4, and that's our first point at 0, 4. Now we're going to do the same thing to our next point we've got at 0, 0. So we're going to write that one down, and then we're going to multiply. But again, 2 times 0 is 0, and 2 times 0 is 0. So our point is going to remain in the same place. Then we're going to grab our last point, which is going to be at +2, 0. And we're going to be multiplying that again by 2. So 2 times 2 is 4. 2 times 0 is 0. And now we've got that point as well. And notice that when we connect our points using a line, or a bunch of lines, we've got ourselves a triangle. Now again, this triangle is not going to be congruent to the triangle we had before. It's going to be similar. It's going to be proportional, but it's not going to be the exact same size. Dilation is the only transformation where the figure will become similar, not congruent. And that's important information to remember. The only transformation that causes the figure to become similar and not congruent is dilation. Now looking at our other example there, it says dilate the figure by a scale factor of 1/2. So again, we're going to need the points before we go ahead and get started. So our first point that we're going to have is at -4, +4. So we got -4, +4. And now we're going to have to be multiplying by 1/2, or we could also be dividing by 2. Because remember, when multiplying by a fraction is the same as dividing by a denominator. So again, if we had to multiply by 1/2, we could divide by 2. If we had to multiply by 1/3, we could divide by 3. If we're multiplying by 1/7, we could divide by 7. Either way is correct. So you can use your calculator if you like, multiply by that 0.5, or you can divide by 2. So I'm going to divide by 2. So -4 divided by 2 is -2. 4 divided by 2 is +2, and that's our first point. So now we have to grab our second point over here, which is going to be at +4, +4. And again, I'm going to be multiplying by 0.5. So 4 times 0.5 is 2. 4 divided by 2 is 2. And that gives us our next point. Going down here to -4, 0. So -4, 0. -4 divided by 2 is going to be -2. 0 times 0.5 is going to be 0. And then we're on to our last point over here, which is +4, 0. And again, 4 divided by 2 is going to be 2. And 0 times 0.5 is going to be 0. And now we have all of our points, which we have to graph. It'll be a little difficult because our rectangle there is rather dark, but we can probably use the lines on the side to help us out. So we've got -2, +2, which is going to be around here. We've got 2, +2, which is going to be right here. We got -2, 0, and 2, 0, and we've got ourselves a rectangle. Again, connecting with our lines. Remember, it is important to know that in dilation, our figure is going to be similar, not congruent. Notice I've got a rectangle, same shape, but not the same size. Now let's take a look at our most difficult and last transformation, rotation. Here we are at rotation, and we have a couple rules for rotations because we can either go 90 degrees clockwise, the direction a clock moves, or 90 degrees counterclockwise, the opposite direction clock moving. So when we're going to be rotating 90 degrees clockwise, the first thing we're going to do is we're going to switch those X and Y coordinates, and we're going to take the opposite of the second coordinate. So when we're going the rotation of the clockwise, we're going to be taking the coordinate that is the second one. So therefore our positive X and Y become Y negative X, because we took the opposite of the X, which is positive, the opposite is negative, and we flip them, so the Y is now in front. Switching over to rotation of 90 degrees counterclockwise, the first thing we're going to be doing is, of course, we're going to be switching our X and Y, and we're going to take the opposite of the first coordinate. So in this case, we're going to be switching the X and Y, so X and Y become YX, and then we're taking the opposite of the first, which is negative Y. Now, how can you remember which one do I flip? Do I change the second one, or do I change the first one? We have a nice little trick for that. So when we're talking about rotating clockwise, which one do I switch between the X and the Y? Well, which way is clockwise? It's the direction the clock goes, so which one do I change? The second one. So you can see I'm going to be using the second one that's going to be changing, and since I'm going to have my clock rotation, I'm going to be going to the right, and that's the one I'm going to be changing. When you're talking about rotating counterclockwise, you've got your X and your Y, and you're trying to figure out which one you're going to be changing. Well, I'm going to be drawing an arrow counterclockwise to the first point, and that's the one that I'll be changing. So again, you can draw a little arrow to help you remind you which one you need to take the opposite of. So now let's see that in a couple of examples. So here we are at a couple of examples for rotation, or as you know it, turn. So the first one, we're going to be rotating our figure 90 degrees counterclockwise, and the second one, we're going to rotate our figure 90 degrees clockwise. So again, the first thing we're going to need is our points, because as we just talked about, we need our X's and Y's. We're going to switch them and then take the opposite of one of them. So starting on the left, the first thing that we need is all of our points. So we're going to put little points here at all the ones that we need, and we're going to be writing them down. So our first point is going to be at +1, -2. Our second point is going to be at negative, or positive 1, sorry, negative 4. Our third point is going to be at positive 6, negative 2. And our final point is going to be at positive 6, negative 4. So now that we've got all our points on there, we have to draw our little arrow to help us remember which one we're going to be making opposite once we switch them. So we can switch them first. If that helps us, we can say, okay, we're going to switch them first, negative 2, and then 1. We haven't made the opposite of anything yet. We just switched them. So same thing on the second one. We're going to just switch them, but we're not going to take the opposite yet. The third one, we're going to just switch them, but we're not going to take the opposite yet, and we're going to just switch them. We're not going to take the opposite yet. So now we need to figure out which one we're taking the opposite of. So we're going to need our arrow. We're going counterclockwise. So we're going to draw an arrow counterclockwise for all of our points. So we're going to be taking the opposite of the first one. So the opposite of negative 2 is positive 2. The opposite of negative 4 is positive 4. The opposite of negative 2 is positive 2. And the opposite of negative 4 is positive 4. So now that we've got all our points, let's graph them and see what happens to our figure. So we've got positive 2, positive 1. We've got positive 4, positive 1. We've got positive 2, positive 6. And we've got positive 4, positive 6. And notice that I have rotated my rectangle 90 degrees. So it looks like it just turned counterclockwise 1 turn. And I did that by switching my points and figuring out which one I need to rotate. So now let's do the same to rotating clockwise. So again, I'm going to need all of my points. So let's go ahead and grab those first. So we got a point here, a point here, a point here. So our first point is going to be at negative 6, positive 5. Our next point is going to be at negative 6, positive 3. And our final point is going to be at negative 1, positive 3. So again, now let's switch them. We're not gonna make any opposites yet. We're just gonna switch them. So 5, negative 6, 3, negative 6. Again, we're just switching. We're not taking any opposites yet. 3, negative 1. Okay, now we need to figure out which way we're going to go. And again, since we're going clockwise, I'm gonna draw arrows that go clockwise, the direction of the clock. So the opposite of negative 6 is gonna be positive 6. The opposite of negative 6 is going to be positive 6. And the opposite of negative 1 is going to be positive 1. So now that we've got our points, let's graph them. We're going to go up 5, over 5, up 6, over 3, up 6, and over 3, up 1, and connect our dots. And notice that our triangle has turned 1 turn clockwise, and that has worked out. Notice that my shape is still congruent. It's the same shape as it was before, same size. Again, rotation is going to produce a congruent shape. Now let's take a look at rotating 180 degrees. Here we are at rotating the figure 180 degrees, or turn, as we talked about before. And this is much easier than rotating 90 degrees. You're going to wish that all the rotations were figures of 180 degrees, because the only thing you need to do is take the opposite of both coordinates. And that makes sense if you think about it. With the 90-degree rotations, we take the opposite of one coordinate. In the 180-degree rotation, we just take the opposite of both coordinates, but we don't have to do any flipping. We're just going to take the opposite of the coordinates. So let's go ahead and grab all of our points off of our graph. So on one side, we've got positive 6. Nope, that's not correct. We have positive 2, positive 6. Our other point is going to be at positive 4, positive 6. Our next point is going to be at positive 2, positive 2. And our final point is going to be at positive 4, positive 2. So again, we're just going to take the opposite of both points. So the opposite of positive 2 is negative 2. The opposite of positive 6, negative 6. The opposite of positive 4, negative 4. Opposite, negative 6. Negative 2, negative 2. And negative 4, negative 2. So we just took the opposite of all of our points. So now we're going to go ahead and graph those. So we've got negative 2, negative 6. We've got negative 4, negative 6. Negative 2, negative 2. And negative 4, negative 2. And notice that our rectangle has rotated 180 degrees and is in the complete opposite quadrant. But again, it is the same when we do rotations. Our figures stay congruent. That brings us to the end of this set of notes. So if you like this video, go ahead and throw us a thumbs up. If you love this video, go ahead and throw us a sub, and we will catch you in the next one.